Hi guys, welcome to Weekend Throttles. Are you curious about how rectifiers work? In this video, we're going to take a step-by-step look at the two most basic types of rectifiers, the half-wave and full-wave rectifiers. First, let's talk about the half-wave rectifier. It's a simple circuit that is easy to set up, but it results in a lot of distortion in the output. Our input AC voltage is VSC, and the output DC voltage is VDC. To create a half-wave rectifier, all you need is one diode. The diode is placed in the circuit so that it only allows current to flow in one direction. This method only allows the positive half of the sine wave to pass through and blocks the negative half. During the positive half of the sine wave, the diode is forward biased and allows current to flow. During the negative half, the diode is reverse biased and blocks current from flowing. The current on the DC side of the circuit flows in one direction, only making the circuit unidirectional. As the load resistor receives from the diode a positive half of the waveform, 0 volts, a positive half of the waveform, 0 volts, etc., the value of this irregular voltage VDC would be VAC divided by pi. Next, let's talk about the full-wave rectifier. This method is a bit more complex to set up, but the results are worth it. This method converts the negative half of the sine wave to positive, resulting in a smoother output. To create a full-wave rectifier, you need 4 diodes. They are placed in the circuit in such a way that 2 diodes handles the positive half of the wave, and the other handles the negative half. During the positive half of the sine wave, 2 diodes is forward biased and allows current to flow, while the other 2 diodes are reverse biased. During the negative half, the previous reverse biased diodes are forward biased and previous forward biased diodes are reverse biased. The value of the voltage VDC would be VAC multiplied with 2 and divided by pi. We saw in the previous section that the single-phase half-wave rectifier produces an output wave every half cycle, and that it was not practical to use this type of circuit to produce a steady DC supply. The full-wave bridge rectifier, however, gives us a greater mean DC value with less superimposed ripple, while the output waveform is twice that of the frequency of the input supply frequency. Full-wave rectifier with smoothing capacitor. Here is how we connect a smoothing capacitor to the circuit. A smoothing capacitor converts the full-wave rippled output of the rectifier into a more smooth DC output voltage. We can improve the average DC output of the rectifier while at the same time reducing the AC variation of the rectified output by using smoothing capacitors to filter the output waveform. Smoothing or reservoir capacitors connected in parallel with the load across the output of the full-wave bridge rectifier circuit increases the average DC output level even higher. Now you know the step-by-step process of how half-wave and full-wave rectifiers work. It's time to take action and try building your own. And don't forget to subscribe to our channel for more helpful videos like this one.